Okay, so we went through the calculations with simple interest. Again, it's really just using those formulas. I just wanted to illustrate why the formulas work and what's really going on. That's what the calculations are telling us. But here's another example. So let's suppose now Mary, I don't know who Mary is, but it doesn't matter, borrows $1,200 from a friend. He agrees to repay the friend at 8% simple interest for 7 years. So it's a 7-year loan. The principal, the initial amount, right, is $1,200. The annual percent rate is 8%. So that's over here. R then is 0.08. So we have R is 0.08. That's this as a decimal. P naught is 1,200. It's a 7-year loan. So T is 7. Okay. So our balance then would be this. Right? So I'm just using, let me go back to this formula here for the balance. We could calculate the total interest, which we will. But the balance though, after 7 years, that's what we're calculating. And that's this. We get 1,200 times 1 plus 0.08 times 7. So I'm plugging in. And then we just do the calculation. And we get this. And that turns out to be this amount. So after 7 years, Mary will owe $1,872. The interest she owes, which is, how much extra she'll pay her friend that she borrowed from, this, right? So that's what's happening here. So that's, another example. Okay, that's good. Oh, sorry. Well, wrong button. Sorry, I pressed the wrong button. But that's happening with simple interest. But now notice, let me go back to here to show you. Here we calculated the interest only in the beginning, right? That's simple interest. And the interest amount doesn't change. But I could calculate the interest each time. In other words, here for this example, right, $50, we calculated it in the beginning. It was 5% of the balance. But I could do 5% of this amount. And then the interest in this year will be different. And that's what I'm going to do in this example. So let's suppose we have $1,000 in an account and the APR is 6%. And we're going to compound it yearly. All that means is we're going to calculate the interest each year. So for year one, the amount in our account, right? It's the principal, which is $1,000, plus 6% of it, right? This is our interest. So we get $1,000 plus 0.06 times 1,000, right? When you do 6% of something, you convert this to a decimal and multiply. So we have 1,000 plus 60. We get $1,060. That's year one. Now, that's year one, though. Okay, year two, well, we're going to recalculate the interest each year. That's what compounded yearly means. We calculate the interest each year. So here, this is the balance, right? The starting balance for year two, which was the ending balance for year one, plus 6% of this. 6% of this. Okay, so what do we have? We have 1,060, right, the balance. But now we're going to add on 6% of this amount. So we're recalculating interest and adding it on. We have 0.06 times 1,060. as you can see. And so we end up with this amount. This is our balance, initial balance that is. This is also the interest that we're adding on. We're not adding on the same interest. It's not simple interest. See, we're adding on more interest. And now this is the ending balance here. I rounded to 2 decimal places, just letting you know. For year 3, we're going to do this again, but now this is our balance. Just like before, we're going to add 6% of it. So we have this amount plus 6% of this, that's our interest. And you can see we're adding on more interest, more than previously. You know, the interest we're adding builds up. I mean, really what's happening is we're earning interest upon interest. And so we end up with this amount. So this is what's happening here. Now, you know, I rounded to 2 decimal places. This is for 3 years, okay? What if we did this for longer? Well, that's what this is telling us. So this is what would happen if we did this for 12 years. Starting balance, you know, the same parameters. The P sub 0 is 1,000. Our APR, you know, annual percent rate is 6%. And so on. So this is what you would get if you kept this up for 12 years. I did this using Excel. I didn't calculate this by hand. So, you know, Microsoft Excel, Google Sheets you can use also. They're spreadsheets. They're really nice, very convenient. But notice, though, the interest keeps on going up. We're earning interest on interest, in other words. In other words, this interest is being added in, and we're calculating the interest on this amount, which includes the previous interest. That's what I'm saying. So we're earning a lot more than we would with simple interest. And this is what we call compound interest. Every time you recalculate the interest, we say we are compounding the account. That's what's happening here. So this is the formula that would tell us how much we would have, you know, t years later. And we do have an exponential function here, notice. Our b, our base, is 1 plus r over n to the n times t. Okay. So again, our balance is A. T is how long the money is in the account, or how long the loan is in years. I mean, theoretically, you could do this in days or something. We're mostly going to stick with years. P naught, as before, is the principal. R is our APR, the annual interest rate in decimal form. Same thing as the annual percent rate. N is how many compounding periods there are in a year, or how many times you calculate the interest. So in the previous example, N would be 1, since we compound yearly, once a year. Okay. And also, I should say this, I think they say this in the book. In these examples, we also assume we're not adding in more money, we're not depositing more money, that is, and we're not taking any money out. You know, it's not like in a bank account where something comes up and you need to withdraw money. We're not assuming that. I mean, you could consider those scenarios, but then it gets a little more involved. So for now, we're not assuming that. But this is our formula. Okay. Let's do an example. So let's suppose, I mean, we did one already, but let's do one now with the formula. Suppose we invest $3,000 into an investment, and the investment is paying us 4%. It's 4% interest compounded quarterly. 4%, that's our APR, annual percent rate. It's compounded quarterly. What that means is it's compounded 4 times a year. 4 times a year. we want to know how much will be in the account, how much it'll be worth, in other words, 15 years later. Okay, so again, we're starting out with 3,000, right? That's the initial balance. So P sub 0 is 3,000. R is 0.04, that's our percent as a decimal. As I said, compounded quarterly. So N in this case is 4. It's being compounded 4 times in a year. We want to know how much will be in the account, 15 years later. So here's our formula, right? P0, that's in front. That's what we have over here. 1 plus R over N. R over N raised to the N times T. Raised to N times T. T is 15. Now, if you're going to do this in a calculator, which I would recommend, make sure you do the parentheses first, order of operations. So you would handle the parentheses first, divide and add to 1, then handle the exponent. 15 times 4 is 60. And so we get this. So this part here I would handle because it has an exponent. That comes first. Doing so, this is what you get. Then you would multiply, and then this would be your answer. So 15 years later, the account it'll be worth $5,450.10. Okay, let me just get the recording. Let me just get the recording.